In this module, we'll start by learning several factoring techniques and use these types of factoring to simplify fractions and find equations with x. So what is factoring? Factoring is actually the opposite of multiplication. So if you can see the first example here, we can multiply x by two terms that are inside a bracket. Now, if you use the result, factoring is finding two things multiplied together that gives you this result. So you can see that it's like a division. The first type of factor we will learn is the common factor, where we have a common quantity that can be factored out or divided out in more than one term. For example, if we have ax plus ay, the common factor is a. So if we take the term a out, we can multiply it by two things, which results in ax plus ay. So a times what will be ax, and that is x, and a times what is ay, and that is plus y. So for example 1, we have again two terms, 4ax plus 2a. So the common factor is not only a, but also the number 2. So you should take out the largest common factor. If not, you just have to keep factoring again. So we take out 2a, we're trying to find what quantity this 2a multiplied by will give us the first term. Okay, so 2a times 2x will give us 4ax. So not only are you looking at the number, but you are also looking at the letters and the exponent of that letter. Now for the second term, 2a times what gives us 2a? Okay, and the answer is not 0 because we are multiplying, not adding. So 2a times plus 1 will give us back 2a. Okay, and this is the answer here. The next example, we have three terms. So when we take out a common factor, there should be three terms in your bracket. Now we're looking for something common in 3x cubed, negative 6x squared y, and positive 9x4 y squared. So now we have to not only look at the number, but look at the letters x and y. So for the number, the largest common factor is 3. And for the letters, we'll start with x. We have x cubed, x squared, and x to the 4. So the largest is x squared, the largest common factor. And for y, there is no y in the first term. So y is not common to these three terms. So now we're going to write three terms in this bracket. So 3x squared times x will give us 3x cubed. 3x squared times negative 2y, okay, will give us the middle term, and 3x squared times positive 3. Now we need another x squared to give x4, and then the y squared. Okay, so we'll do a couple more examples with common factors. Now you can pause this video and check your answers in a minute. Okay, so for example 2a, the common factor is 5a squared x squared. We'll have three terms in the bracket, and that will be a minus 1x plus 2z. For b, the common factor is 3ab, and again, there are three terms, so that means we have three terms in the bracket. And that gives us 4b minus 2a and plus 1, right? Not 0. We need to multiply by 1 to get the same term back. And for 2c, the common factor is just x. And that leaves us with 5x minus 3 plus 8x squared. Okay, now we go on to another kind of factoring, and that is the difference of squares. Now, the difference of squares is a result of two binomials multiplied together. So you probably learned this in Math 1. Here, maybe I'll start by working backwards here. If I multiply a plus b times a minus b and expand, there are 4 multiplications here, right? So a times a times negative b. Okay, now b times a, which is plus BA, or in alphabetical order AB. So it doesn't matter if you write BA or AB, it's the same product. And the last multiplication, you get negative B squared. Now notice the middle terms, when you add them together, they add to 0. You have negative 1AB plus 1AB. So this is really a trinomial with the middle term is 0. So that means there are two things multiplied together that will result in a squared minus b squared. And that is, of course, the two binomials, and the middle term is opposite. That's what makes the middle term equal to 0 when you add those. So there are factors for a difference of squares. Now, there are no factors for a sum of squares. Not in real numbers. When you learn complex and imaginary numbers, there will be, but not in real numbers. So that is prime. Okay, a sum of squares is not factorable. Okay, oh, there you go. So for letters, we want to have exponents that are even numbers. So a squared, a to the 4, x to the 6, those are all perfect squares. And as for numbers, we're looking for perfect square numbers. So 1, 4, 9, 16, and so on. Okay, so be comfortable to know your perfect squares. So I'll do a couple right away, and then you can pause the video here and just work on your own. For x squared minus 9, we have two perfect squares. 9 is a perfect square, x squared is a perfect square, and there's a minus in the middle. So that means there are two brackets. The leading term is x times x, because that'll give us x squared. And the last term will have a plus 3 times negative 3 gives us the product of negative 9. And you can check that the middle term, okay, results in plus 3x minus 3x, which is 0. Okay, the next one, now there are no numbers, but the letters, notice that the exponent are even numbered. Okay, so that means there are two things multiplied together is a to the 4, which are the same, right? A squared times a squared is a to the 4 when we multiply that out. Now for B6, really all you have to do really is to divide the exponent by 2. Because when you square something, when you square something that's already raised to an exponent, you multiply exponents. So if you divide the exponent by 2, you'll see the perfect square, right? So in other words, this is b cubed times b cubed. One has to be positive and the other one has to be negative to have a result of negative 6. Okay, the next one's kind of tricky, so maybe I'll just go on here. Now we're not going to expand this bracket squared. It is a perfect square because of the exponent 2. Y squared is also a perfect square, and there's a minus in the middle. So this is a difference of squares. So the first term, y times y, is y squared. Now keep this bracket as a whole. Just pretend the bracket is b or a or another variable. So you'll have x plus 5 bracket times negative bracket x plus 5. That will give us the negative bracket squared. Now you can expand here in your second bracket. So I'm going to continue. There's a minus in front, so that'll affect each term inside. Okay, and again, just pause the video anytime and you can see the solution later. Now for D and for a lot of the other factoring techniques to come, a hint here is to always look for a common factor first. That should be the first thing that you should look for, because there are going to be more factoring methods in the lessons to come. And all of them, see if you can see a common factor, because 75 is not a perfect square, but there is something common in 75 and negative 3a squared, and that is a common factor of 3. So take the 3 out first. Now you can see the remaining terms in the bracket are two perfect squares. We're going to keep the 3 in front of the leading bracket and then write two brackets. So this has to be 5 plus a times 5 minus a. Okay, is not the same as a minus 5 times a plus 5, because here the a is positive, or in this case a squared, and the negative is on the 25. Okay, that's not what we had here. We had a positive 25 and the a squared term is negative. Okay, so be careful of the order. For number 4a, we have a common factor of 5. And then a difference of squares. For b, the bracket is squared. So pretend this bracket is like the letter x or y. And 9x squared is also a perfect square, but there's a minus in front. So this is the negative on the 3x. Now you can drop that smaller bracket inside. And nothing adds together here, so we just leave it like that. There are no terms to group together. For C, now we have to completely factor this. There's going to be two different kinds of factoring. M squared times m squared is m to the 4, and 4n squared times negative 4n squared is the negative 16 n to the 4. Now if you notice, the second bracket is also a difference of squares, not the first one, because the sum of squares is a prime term. So we have to completely factor to 3 brackets. For D, this is just a reference here, because for those who are in civil, we'll see this again in a beam deflection. Here we have a common factor of P and B. Now PB is two separate quantities here. It's not the same. So it's P times B times L squared, and here P times B cubed. So the common factor is P times B, and we're left with L squared minus B squared, which again is a difference of squares. So completely factor, and you get this. Okay, now the homework, this is assigned homework for your reference only. It is not to be handed in. I will let you know when it will be an assignment or a quiz. Now this homework is in the 11th edition of your textbook. Okay, so try it out and we can maybe do a few of these questions in the live tutorial.